In this lesson, we will look at how engine propellers are protected from the effects of icing. Ice formation on a propeller blade produces distortion to the aerofoil section, causing a loss in efficiency and possibly causing unbalance, which can lead to destructive vibration. The build-up of ice must be prevented, and this is usually done by electrically heating the propeller blades. Because of its thickness and lower speed, the inner third of the propeller blade is most susceptible to icing, and is always de-iced. In some installations, the middle third is also de-iced. The outer third of the blade is not so susceptible to icing, and is not normally de-iced. The electrical heating elements are usually fitted in components known as overshoes or boots. The construction of the overshoes varies between propeller types. In a common installation, the heating element wires are interwoven with glass threads, which form a glass cloth base, which is cemented between sheets of rubber. A protective guard of wire gauze is cemented beneath the outer rubber covering. The overshoe is shaped to fit around the blade leading edge and is cemented to it. In the case of turbine engine propellers, the cover over the pitch change mechanism, or the spinner as it is known, may also have electrical heating elements embedded in it. Depending on the type of aircraft, the electrical power for heating the elements is either direct or alternating current. These systems consume a relatively high amount of electrical power. However, they are controlled by employing a cyclic timer, which will de-ice the propeller blades of one engine at a time, thus reducing the power requirement. In some installations, a power relay is fitted in the engine nacelle. It allows the length of heavy high current wiring to be kept to a minimum, with light cable being used in the control circuit. In turbopropeller engine installations, the propeller heating circuit may form part of a power unit de-icing and anti-icing system, with the cyclic control being integrated with the engine air intake heating circuit. The power required for heating is conveyed to the elements via cables, slip rings, and by brushes, contained within a brush block housing. Slip rings and brushes are components used to transfer electrical power from a stationary part to a rotating one. They are fully explained in the Electric Systems series of lessons. In icing conditions, during the unheated period, a thin film of ice will build up on the leading edges of the propeller blades. Before this film builds up sufficiently to interfere appreciably with the aerodynamic characteristics of the blades, the cyclic control applies heating power. The ice in contact with the blade surfaces melts, breaking the bond between the ice and propeller blade. The remaining ice is then carried away under the action of centrifugal and aerodynamic forces. That is the end of the lesson on propeller ice protection. You should now know that electrical propeller de-icing is usually done cyclically, and that on turbopropeller type aircraft it may be integrated with the engine ice protection system.